Hey everybody, welcome back. Now we're going to start on a new section, adding on to what we have already learned about atomic structure. Right. Now we're going to go in and we've learned the hard way of doing Bohr model and putting all the electrons all around the nucleus that holds our protons and neutrons. Now I'm going to go through, we're going to review that real quick, and I'm going to show you the easiest way to see valence electrons and how to put them. That whole thing of doing the Bohr model, yeah, I mean, it all goes a long way around. It's better to know how to do the long way and then bring it into the simplified way, which will lead us into bonding later in the week and be able to combine two elements to make a compound. So making water, H2O, how we can watch the electrons be able to connect between hydrogen and oxygen and another hydrogen to make water. But first, let's go through and learn about Lewis dot. So let's go ahead and review what we learned last week. And as you can see on my screen, if you guys are remote, you will be doing this in your journals and your notebooks. If you are face-to-face students and you are absent, watch the video so you can be up to speed when you come back to class, and I'll give you the note sheet to be able to continue when you come back in. So this will be review from last week. We have, so as you see, our topic for today is Lewis dot structure. We are going to go ahead and review. Let's see, let's make this nice and bright. So atomic symbol, for us, when we look at the periodic table, we look at a tile. So it can look like this one, or you can see the big screen of a periodic table. No matter the way it looks, you're going to have a number on top. You're going to have one or two letters. You're going to have the name of your element, and you're going to have the atomic mass. Now, these two can be flipped. One can be on top of the other or reversed. It depends on which periodic table you see. But you should know at the very bottom of your element tile, your atomic tile on the periodic table, it will be your atomic mass and your element name. So let's go ahead and review a few things. We have the atomic symbol, which denotes our element, or I'm going to make that a little bit more pretty. So it denotes our element in a short form because I seriously don't want to be writing California all the way through. So I would just do CF for California. Or neon. I'm efficient with my time. I know neon has Ne for its atomic symbol. I don't have to write the whole name out. So the atomic symbol are just the letters that denote our element. Our atomic number is the protons, which identify our element. And our atomic number is always on top. No ifs, ands, or buts about it. Atomic number is always the number on top. Our atomic symbol are the letters. And let's do another color, orange. Our atomic mass, remember, it are our neutrons. Misspelled that. Hold on. Neutrons plus our protons. And that is always on the bottom. Okay. So it's the neutrons plus the protons equals our atomic mass. A good way to remember that, because I do like to have mnemonics. We have ape. Choose a different color. We have ape man. Okay, so if we take ape, we do the atomic number. So atomic number equals the number of protons, which also equals, if we are talking about a neutral element, okay, and we will understand more about non-neutral compared to charged, or what we call ions, in just a few weeks. So if it is not a charged element, our protons will equal our electrons. So atomic number for a neutral atom, protons will equal electrons. Now let's go to man. So it's the mass, the atomic mass equals, oh, I'm sorry, not equals, minus, or if we subtract, so that's a subtraction sign, the atomic number. This will equal the number of neutrons. So mass minus atomic number equals neutrons. Okay? So now that we have that, if you see a periodic table, you see an element tile, atomic numbers on top, and it's the atomic symbol, the mass of the atomic element, and then the name, or those two, the mass and the name can be flip-flopped. So let's go down. Y'all remember this lovely, wonderful circle. This is our Bohr model that we were working on last week. Here I have the element chlorine. Okay, we are going to take chlorine and fill in our Bohr model. So what I want you to do real quick, pause the video and see if you can do this on your own. I want you to tell me the protons and the neutrons, and then fill in all of your electrons. So draw, for you guys doing this in your notebook, you can write the tile of chlorine in your notebook. Then you can go and write the atomic number, which will equal, what will your atomic number equal? Since we are talking about a neutral atom. Then you're going to tell me your atomic, excuse me, you should know your atomic mass because it's on the tile. Tell me your neutrons. How many neutrons do you have? So pause the video and see if you can work on this and figure this one out. Okay, so have you figured this one out? I'm going to do the orange. So for chlorine, if you notice our atomic number is 17. We have 17 protons. So you can either see it as P plus. Let's go back. Let's find out how many neutrons do we have in chlorine. We like to work with whole numbers. We can't have a partial neutron, remember? We have to have a whole number for our atomic mass. But the thing is we have a decimal in our atomic mass. Not going to work. That is not going to fly. So we need to round this number to a whole number. The number that will figure that one out is the one that's in our 10th spot. The 10th spot will tell us, hey, do we need to round up or do we need to round it down? 0.4 is closer to 0. So what we will do is we will take 34.5. We will round it down to 35. Okay, so to find our neutrons, we're going to take 35. Oh, I'm going to do this, hold up, because it's atomic mass minus atomic number equals our neutrons. I do this over and over and over, repetitive, because it's going to help you. So 35 minus 17. What would that be? Get your handy dandy calculators out and do 35 minus 17 and then write it in your journal. I've got to write something down underneath. So I'm going to take this real quick and adjust it. There we go. So 35 minus 17 is 18. So we have 18 neutrons in chlorine. And that is fine if the protons, not proteins, protons are not equal to the neutrons. That is perfectly okay, and it's going to happen. Because remember, neutrons do not have a charge. They're just to hang out. They're good. They're there to balance everything. So neutrons, we have 18 neutrons. Since we are talking about a non-charged, or what we call a neutral atom, we have just the same number of positive protons as we do our negative angry electrons. So how many electrons do we have? 7. If you guess 17, you are right on the money and you are awesome. Quick question. Do we start on the nucleus wall? No, we do not. We start outside of the nucleus wall, so the very first energy ring. It does not matter if you start here, 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 or here. Just pick one. And remember, how many electrons does that first ring have? 1, 2. It only has 2. Now that that ring is completely filled, we're going to go to the next ring and start filling that in. You're going to go pick one side. You can either top, right, left, or bottom. But when you do that, you have to stick to it and then go around one time, place in one electron. And then place the duo next to when you go back around. So as I'm doing here, I did the top. Now I'm going to my right and go all the way around one time. Okay, so that is 6, 7, 8, 9, I have 10 electrons. I have, let me change this color. I have 2 and I have 8. So that is 10. But I have 7 more. What do I need to do with those 7? I will go 1, 2, 3, 4, 5, 6, 7. I'm all done. I'm out of electrons. I can't add any more to this element because it will not hold it. But there's something that's not quite right. Chlorine has one free space on its outside energy shell. This very last shell holds the valence electrons for our element. So right down here, I'm going to be like, okay, my valence electrons live, or you can say located, I'm going to put located, are located on the very last I'm going to fix my R. Very last energy shell of an element. So the very last energy shell is the very last one where that's the end of the road for all your electrons. You either completely fill it with eight electrons because that's the max it'll hold, or you wind up with 7, 6, 5, 4, 3, 2, or 1. Okay? And we'll see that as we go through. So this is going to be very important, the valence electrons. Now that we've done our Bohr model and we've had to fill in all of the electrons for chlorine, I'm going to show you the simple way, because all of these electrons right here, we really don't care about them. We really don't. All we care about are these valence electrons, because those are the ones that are going to tell us how many elements chlorine can bond to at once. So let's go down and we'll figure out and see how chlorine's valence electrons look. So again, we went through the periodic table, the element tile. Now we're going to go down. We're going to practice our Lewis dot structure. We're going to look at hydrogen and beryllium first. So if you look at hydrogen on your periodic table, hydrogen is in period 1, group 1. It has, so we do this, so group 1, period 1. So remember, groups go from left to right, so it's the columns going up and down, all the way down your periodic table. Periods are the numbers going from top to bottom, and they run on rows, like this. So periods are your rows, groups are your columns. Groups tell us the number of valence electrons in an element. The rows tell us the number of energy shells the element has. Okay. Ooh, there you go. Sorry about that. So I have hydrogen. Hydrogen is on group 1, period 1. So they only have one ring. We know that. And hydrogen, if you can tell by with it being in group 1, 1A, we know hydrogen has one electron. And it's only one ring, so it has one valence electron. So what we're going to do is I want you on your paper to draw the H, just like this, and I want you to lightly draw a box right around it. Now this box, and that one really does not, let me draw my square a bit better. Now this box is our border. This box is what's going to hold our electrons in place as we go around placing our valence electrons. Hydrogen only has one valence electron because it's in group 1, period 1. So group 1, one valence electron. We're just going to take our electron, our uno electron, right on that line. Guess what? I'm done. I don't need to do anything else for hydrogen. We're done. We're done. It's that simple. I told you I made y'all do the long way around last week. So remember, hydrogen, group 1A, had 1 valence electron. Let's go to beryllium. Let's write the atomic symbol for beryllium, which is Be. Lightly draw our border. Okay. Beryllium is in group 2A. So if you remember group 1A, 2A, we're not going to mess with the metals right now. So don't worry about the transition metals that are in the middle. We're not going to worry about. Let me show you something real quick. Atomic structure right here. So here's your periodic table that we usually look at. We are not going to worry about this right here. All of this stuff in the middle, we're not going to worry about. We just are focusing on our group 1A, 2A, 3, 4, 5, 6, 7, and 8A. That's all we care about right now. It might change in a little while, may not. But right now, that's all we're focusing on, are those 8 columns. Now let's go back real quick to this. We have beryllium. Let's check out where beryllium's at. Beryllium is in group 2A. If it's in group 2A, because we know our groups go from left to right, and it equals our valence electrons. How many valence electrons does beryllium have? Oh, that would not be cool. 2. So go back here. This is what I was telling you. We don't group electrons together until we go all the way around. So when you're doing this, you go 1. Now I want you to get into a habit of doing opposite of each other. So 1, 2. Beryllium's done. That's all we need to know, because we know beryllium has 2 valence electrons. Beryllium will only be able to bond with 2 other elements at one time. That's all that means. So group 2A, only 2 valence electrons. Put those in there and you're done. Let's go on, and we're going to look at helium. You see we have the Bohr model. I just realized I made a goof. Right. Hold up. 1, 2, 3. Yep. Yeah, no, I'm good. Yeah, my brain was not wanting to compute at that moment. So helium's a little different. Okay, helium is our oddball out. I know going from beryllium, going in the scale, how does helium and beryllium have the same valence electrons? How does that happen? Let's look at this for a second. Beryllium, if we drew the Bohr model, I'm just going to put Be in the middle. This is our first ring, our second ring. Okay? Beryllium has an atomic number of 4. So we know it has 4 electrons when it's not charged. So if we do that, we go, this is not a nucleus. I'll do this. So here's my nucleus wall. So I don't confuse you. I have 1 electron, 2 electrons. Those are my first 2. And that's 3, 4. Okay. So my valence electrons for beryllium are right here. And it only holds 2 on that second ring. Now let's go back to hydrogen. If you notice hydrogen, here is our nucleus for hydrogen and our one ring. Hydrogen is on group 1, or excuse me, period 1, group 2, or group 8A. I do apologize. I'm sorry. My brain's not want to work. Helium is in group period 1. Period 1. Let me go back to mine. There we go. Let's go with this one. Periodic table. And I will clear this out. And I will draw on this for a second. So helium, this is period 1, 2, 3, 4, 5, 6, and 7. And my groups go this way. And periods go this way. So periods run top to bottom. I'm going to clean this up. So this is periods. Go from top to bottom. There we go. And groups, left to right. Our periods tell us the number of rings. Groups tell us the number of valence electrons. Helium is our weird dude. Helium is on period 1 all the way across. So it's period 1. It only has one shell. That's all it has. That's the reason why it's on period 1. But you're like, Ms. Gale, the valence electron says 8. How has that happened? Well, if you notice, since helium only has one shell, and the first shell only holds 2 electrons, it can't hold any more. That's it. That's a rule. That's the rule we have to live by. So helium is on 8A because its valence electrons are completely filled. It's happy. That's why it's there. I know it's a little wonky, but because its shell is completely filled, we call it noble gas, and it's happy. It doesn't need anybody else. It can be like, yeah, go away. I don't need to. I'm happy. So with that, helium has one ring. Let's go back here. We're going to draw our black. Here we go. Draw our atomic symbol for helium, and we're going to draw our little box around helium. All right. I think I'm going to clean that up. Okay. Helium is on period 1, all the way across, one ring, but it has 2 protons and 2 electrons. One ring. That's it. So 1, 2. Okay. Let's go down to potassium. Simple as pie. We do potassium, atomic symbol K. We draw our little shadow box. If you notice, this is why we do the Lewis dot structure. Look at all of those 19 electrons of potassium. I hate to admit it. I don't like using the word lazy. I'm efficient with my time. Why do I want to draw all of these little dots, okay, when I really don't care about them? All I care about is this pretty little one on the outside. That is the only one I care about. That's it. So potassium is in group 1A. So if you go take your periodic table, our lovely potassium is right here. It's in group 1A. All those other 18 electrons don't really matter. So all we have to do is go, ooh, potassium, you're so simple. I don't want the highlighter. Potassium, you're such a simple girl. You just need one. That's it. You done. And potassium, when we get to bonding, can only bond with one other element. Okay? Here's another thing why we don't do the Bohr model. Look at the obnoxious iodine Bohr model. I'm not drawing all that crap. Again, I'm efficient with my time. I'm a mama too. I work for a living. I don't have all the time to be drawing all these dang gosh darn dots. So, easy way. Let's go to this efficient, time-saving, lovely way. Go make our little box. Let's find what group iodine is in. So let's go back to our periodic table. Let's search for iodine. Nope, not there. Nope, not there. Look for I. Nope. I. Nope. Oh, found him. So iodine is in group. Let me get a. Is in group 7A. So if he's in group 7A, how many valence electrons do you think he may have? So if you want, we can even count them real quick. Let's go and do this. We have 1, 2, 3, 4, 5, 6, 7. Group 7A, 7 valence electrons. So 1, let me go to a darker color. 1, 2, 3, 4, 5, 6, 7. Easy peasy. All done. Iodine is done. We don't have to mess with him anymore. But he doesn't have a full shell. So let's think about this for a second. He only has 1 electron. He has a lonely electron. It doesn't like to be lonely. It does not like to be lonely. It wants a buddy. So to this, we would think when we get into bonding later in the week, he wants a buddy. So he will have to have 1 extra component come in. So he will bond with 1 other element. And that's it. For him to be happy and be full, he will need 1 buddy. So let's go down to carbon, my favorite element on the whole periodic table. And for you guys in class, if you've heard this, here's why carbon is my absolute favorite element. Carbon does not discriminate who he bonds with. Okay? He doesn't. He will bond with anything and everything. So if you can think of anything that may relate to somebody that likes to bond and be with everybody and anybody. So let's go and play with carbon for a second. We have carbon. Let's draw our little box. And let's go back to our periodic table. We have, let me erase this. Erase this. Let's look for carbon. Nope. Oop, there's carbon right in the middle. So carbon, our wonderful free-loving carbon, is in group 4A. If he's in group 4A, and our groups tell us the number of valence electrons in an atom, how many valence electrons do we have for carbon? 4. So we go 1, 2, 3. Let's do that. And 4. Let's go to our Bohr model. It's right here. Let's see if we did this correctly. 1, 2, 3, 4 valence electrons in the Bohr model. Awesome. Super. Lovely. Wonderful. Oh gosh darn. Polonium. Madame Curie. She was one witch little woman. She discovered polonium, and do you see all of those gosh darn electrons? That is a hot mess. A severe hot mess. I'm not doing all of that. So guess what? What can we do instead? Let's do the efficient way. So we can do polonium, PO, our atomic symbol. Draw our little box. And go on your periodic table and find polonium. Where does polonium live on our periodic table? Pause the video, go look up your periodic table, and find out what group. And here's one right here if you want to look at it. Pause it and see if you can find it. So it's PO is polonium. Oh, there's polonium, number 84. 84 electrons. I don't have that kind of time. Not happening. So let's make this easy on ourselves. We have, he's in group, yeah, 1, 2. Remember, we don't worry about, where's my red? We don't worry about any of this right now. We're not concerned with that. So let's go back to the highlighter. So it's 1, 2, 3, 4, 5, 6. Up. He's in group 6. How many valence electrons? Do you say 6? Let's try it out. Change to black. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, I can count tonight. Woohoo! So 6 valence electrons. Let's go and check on our Bohr model real quick and see if we did this correctly. Let's do this. Our valence electron shell is this outer ring. Ooh, right there. No, let's count them. So we have 1, 2, 3, 4, 5, 6. Hooray, we did it. And we don't care about any of you. Nope, we don't care about you. And yeah. So when we get to bonding, polonium has 2 free electrons that need a buddy. So we will learn later in the week that these 2 electrons will want a buddy from another element. Okay? So if we recap what we just did, I'm going to put this back. Let me draw this a little bit better because y'all know I'm a little bit, I can't draw to save my life, but I try. So there's that, and there's, go back to gray. And there's my 6th. So let's recap real quick of what we just covered. So we reviewed our periodic table, our atomic symbol, our atomic number, atomic mass. We went back and looked at our Bohr model from last week, which is the long, drawn out, tedious, obnoxious way to fill out our electrons. We learned that valence electrons are located in the very last energy shell. Let me read this. It's the electrons located on the very last energy shell of an element. And those are the ones we care the most about. The other ones, they're just fodder. They're fine. We want those last ones. We noticed that hydrogen has only one electron, only one valence electron. Beryllium has two valence electrons because it has two rings. That second ring only has two in there. We learned helium has two, potassium has one, iodine has 7, carbon has 4, and polonium has 6. So when we do this, it makes our life a lot easier when we go to start doing bonding, which we are going to start covering later in the week, like I've said a couple of times. So until then, which is going to get a little bit more, a little harder and a little bit more time consuming. So until then, I will see you next time. Y'all have a great day and hope y'all start liking chemistry. Bye.